Now we're going to take a look at the graphs of quadratics since we've been solving them for so long. The graphs of quadratics are called parabolas, which hopefully you talked about back in Algebra 1. They have a maximum or a minimum, which is called the vertex. And another key piece of vocab for quadratics is something called the axis of symmetry, which always goes through the vertex. And I usually abbreviate that AOS. And in this unit, we're only dealing with parabolas that open up and down. And so our axis of symmetry is always x equals the x value of the vertex. X equals the x value of the vertex. All right, so when we do these equations, there are actually three different forms of my parabola that each tell me different things. So my standard form equation looks like y equals ax squared plus bx plus c. An important thing here is A tells you whether it opens up or down, and also it tells you the width. Is it skinny or fat? So width. Then C, the other important thing here, C is my y-intercept. So standard form gives me my A, does it open up or down? Is it skinny, fat, or normal? And then it gives me my y-intercept. There's also something called intercept or factored form. You'll see either. It still has A, and then we do x minus p, x minus q. Don't ask me why it's p and q, I don't know. So A is still the same thing. So A tells me whether I open up or down, and it tells me the width. Then intercept form gives you what? The x-intercepts. So P and Q are my x-intercepts. So the whole time we've been solving by factoring, by the way, factored form looks like this, and when I solve by factoring, it gives me my x-intercepts. Just blew your mind. Vertex form is y equals a times x minus h squared plus k. A still is doing the same thing, up, down, and width. And now here, I have my vertex, that's the name vertex form, is HK. So this should be tying in with some things that you remember. You don't need to write what I'm writing in red, but this ties with factoring and solving by factoring. And vertex form connects with transformations. When we talked about reflecting over the x-axis, when we talked about vertically stretching, vertically compressing, moving right, left, up, and down. So vertex form is the form I would use if I'm thinking of it in more transformations. So now I have this spot for A. So this A is the same as it was when we did transformation. So if A is negative, it means it's reflected over the x-axis. And for this unit, that means I just need to know it opens down. And then A also gives me my width. So if it's greater than, the absolute value is greater than 1, it's going to be skinnier. If it's between 0 and 1, it's going to be a wider parabola. The other thing is how to find A from a graph. So to find A from a graph, we usually want to use either intercept or vertex form. And then once we do that, you choose a point. Plug in known values. By that I mean if I'm intercept form, I plug in my intercepts. If I'm vertex form, I plug in my vertex. So plug in known values and solve for A, which we'll look for on the next slide. So here's two lovely parabolas you might have seen. So the first thing I want us to do is say which way it opens. So this first parabola opens up. My x-intercepts, where it crosses the x-axis, would be at -3, 0, and 1, 0. I have a y-intercept at 0, -3. My vertex is -1, -4. That's really saying I have a relative minimum there. -1, -4. And then AOS stands for Axis of Symmetry. And in this unit, it's going to be x equals the x value of the vertex. So the x value of the vertex is -1. So my axis of symmetry is the line that cuts through my parabola. It cuts it in half. Okay, I have to have the x equals because the axis of symmetry is a line. Then I'm going to circle whether I have a maximum or minimum. Do I have a maximum or a minimum on here? I have a minimum. And the minimum value is the y value. So that would be -4, the y value of my vertex. Range, we should be okay doing range now, right? So my lowest value is down at -4. And I go up to positive infinity. -4 up to positive infinity. Now I didn't ask for range, or sorry, domain, because domain on parabolas, quadratics, is always -infinity, positive infinity, if you want to write that down somewhere. And then we're going to move to intercept form and factored form. So, intercept form, which is factored form. So y equals, we're going to leave our a blank for right now. And then we want to do x, and what I do now is I go to my intercept. So I have an x-intercept of -3, and we switch the sign, so that's going to be a +3. I have the 1, switch the sign, that's a -1. And this is because, remember, to get the x-intercepts, what we did was solve. So if I do x plus 3 equals 0, solve that, I get x equals -3, which is my x-intercept. And now let's look at an example of solving for A. So you should have a little bit of space on the side. I'm just going to come over here. So I have my equation, y equals a, x, we have +3, x minus 1, and I'm just going to choose a point. You want to choose points that have, nice coordinates on there. So I'm going to choose the point on my graph 0, -3. So let's do 0, -3. So that means everywhere I see an x, I'm going to put a 0 in my equation, and everywhere I see a y, I'm going to put a -3. So -3 equals a times, everywhere I see an x, I put 0, 0 plus 3 times 0 minus 1. Notice I chose a really nice value. I try if there's like something with 0 or 1 or something, I try to do that because it makes it nicer. Okay, so -3 equals a times 3 times -1, just 0 plus 3, 0 minus 1. So -3 equals -3a, so a equals 1. So in my equation, just a equals 1. And once I've done that for one equation, I don't need to do it anymore for that same problem. So y equals, we already found the 1. And vertex form is what it looks like with transformations. So we have something squared, and we put in our vertex. So my vertex I've done in red. So it's inside, so it's opposite. So x plus 1, and then outside we keep our k, minus 4. Think back towards transformations. If I gave you this and asked you to tell me a transformation, you would have said left 1, down 4. So the vertex is left 1, down 4 from origin where it started. Okay? So I'm going kind of slowly through this first one just to make sure that y'all are all tracking with me. And then we should also still be able to tell me things if I asked you increasing, decreasing, positive, negative. I'm not going to take time in this video to do that, but you should still be able to do that. All right, so now let's look at this one. I'm going to pick it up a little bit in terms of speed so that I don't totally lose you. All right, so direction, this one opens down. Then my x-intercept, I only have one. I have one x-intercept, which means it's something special called a double root, which we have briefly mentioned. So if you want to write that down, let's write that down actually. Double root. That does become important. My y-intercept is down here at 0, -9. My vertex is also 3, 0. Notice that's always going to happen because I have that double root right there. So when I have a double root, that's also my vertex. My axis of symmetry is x equals the x value of the vertex, which is 3. This graph has a maximum. The maximum value is the y value of my vertex, which would be 0. My range, how low do I go? I go down to -infinity, and I go up to 0, straight bracket. Maybe you've noticed, but my max value is my endpoint for my range. My min value on the left is my min value for my range. Okay, so intercept form, y equals something times something. All right, x, this double root means it's showing up twice. So I had x is at 3, 0, so I need to put x minus 3, x minus 3. It happens twice. Now, let's think about that. Can I rewrite that? If I multiply something to itself twice, what is that? X minus 3 squared. So I have my vertex, which was 3, and then plus 0. Do I really need plus 0? No. So both of these are the same, and let's try to find our a value. I'm going to use the vertex form one this time. So y equals a times x minus h squared plus k. I'm just starting all over on this one to make sure we're good. Y equals a, x, my vertex is 3, 0, so minus 3 squared plus 0, but I don't need the plus 0. All right, so let's choose a point that's not the vertex. If you do the vertex, you're just going to go around in circles. So I'm going to choose the point on my graph, any point. I'm going to choose the point 1, -4. You just need to make sure it goes through an actual corner. So -4 equals a times 1 minus 3 squared. So -4 equals a times -2 squared. So -4 equals 4a. So a equals -1 in this problem. And I could have chosen a lot of different points. It just needs to go through a corner. Okay, so the next one opens down. I have x-intercept at 1, 0 and 5, 0. A y-intercept at 0, -5. My vertex is at 3, 4. My axis of symmetry is x equals the x value of the vertex. This graph has a maximum, and the maximum value is the y value of the vertex, and that helps me with my range. It goes down forever to -infinity, and then goes up until we hit 4 with a straight bracket. So my intercept form would be y equals something, parentheses x, parentheses x. So I go back to my intercepts, and I change the sign. So instead of +1, I put -1. Instead of +5, I put -5. And I'm going to go ahead and solve for a on this one. So y equals a times x minus 1, x minus 5. So I get, let's choose the point, let's choose one of the, let's choose my y-intercept. So 0, -5. I like zeros and ones. -5 equals a times 0 minus 1 times 0 minus 5. Whoops, I ran out of room. That's okay. Not the first time. -5 equals a times -1 times -5. So -5 equals 5a, and a equals -1. Is a always 1 or -1? No. It's just the most boring one to start with. I actually don't think on this one I chose any fun ones. Well, that's a bummer. We'll do some in class. All right. Then for my vertex form, that's where it looks like transformation. So parentheses x squared. And now I go look at my vertex, and I'll do this one in blue. So I would do x minus 3 plus 4. Look at your graph and think about transformations. I have reflected over the x-axis, that's why I'm opening down. And then my vertex is usually at 0, 0, but now my vertex has moved right 3, up 4. Transformations are really and truly the best way to think about graphs. All right, last one. Direction is opening up. Do I have any x-intercepts? No, so I have no x-intercepts, none, which means I'm not going to have intercept form. This also means if I was solving with quadratic formula, I would get imaginary solutions. My y-intercept is at 0, 8. My vertex is at -2, +4. Axis of symmetry is x equals the x value of my vertex, so -2. This graph has a minimum, and my minimum value is the y value of the vertex, which is 4. That helps me with my range. My lowest value for my range is 4, and then it goes up to +infinity. So now let's finish off by writing our vertex form. Y equals something squared. Put our x. I'm going to go ahead and put my vertex in there. So my vertex was -2, 4. So x plus 2 plus 4. Remember, everything right and left is opposite. If it's inside with x, it's opposite what is intuitive. So I have to do it with vertex form this time since I don't have an intercept form. So I write my equation, and I choose a point. So this time, let's try the point -1, 5. So 5 equals a times -1 plus 2 squared plus 4. So 5 equals a times 1 squared plus 4. 1 squared is just 1, and a equals 1. I told you, all these are boring. I promise there are more interesting ones in the universe.